In this video, we'll be solving this last improper integral of type 1. I have the top bound, which is infinity, so that means it's improper. If I just stare at it, I notice that it's not the easiest of integral. In fact, because I have log of x and it doesn't quite work with substitution, this is going to be integration by parts. So when I have an integral that's tough with not only bounds but infinite bounds, what I like to do sometimes is just compute the integral separately without bounds and then afterwards come back with the bounds. That's what I'll do here. Alright, so let me solve it here. Alright, so let me write it as x to the minus 2 log of x. That way I see the product that's going to lead us to integration by parts. I have something that's algebraic, something that's logarithmic. So I should take u to be log of x, du will be 1 over x dx, v is x to the minus 2. And so v is x to the minus 1 over minus 1. Alright, so I get u dv, which is minus log of x over x, minus the integral of v du, so minus 1 over x squared dx. And so I get minus log of x over x plus x to the minus 1 over minus 1 plus c. I get minus log of x over x minus 1 over x. Alright, so I've done this on the side so I don't have to do it with both a limit and with bounds. And now I'm ready to tackle this one. Alright, before I can use the formula I found on this board, I'm going to have to first rewrite it as a limit. So I'm going to get the limit as t goes to positive infinity, e to the t, log of x over x squared dx. So I've replaced this infinity here with the t, and I sent t to infinity using a limit. Now for this part, I'm going to use FDC. I have the antiderivative over there. So I'm going to get the limit as t goes to positive infinity. I'm going to have 1 of x. Let me put it together. I mean, the same denominator. They have the same denominator, so might as well. So plus 1 divided by x. And I'm going to plug in e, and I'm going to plug in t. Alright, so this is FTC part 2. Now I'm going to plug the two bounds, the top one first. Top one gives me log of t plus 1 over t. Second gives me log of e, which is 1 plus 1 over e. This is just a constant, so it doesn't need the limit. If I plug in infinity, I get infinity over infinity here, so I'll be using L'Hopital for that part. So let me split it up into two different ones. I have log of t plus 1 over t, and I have plus 1 over e. Now I'm going to use L'Hopital here since I have infinity over infinity. I I have 1 over t as the derivative of the top. I have 1 as the derivative of, sorry, that was a 2 here. Let me put it in blue so you can see where I went wrong. This should have been a 2. 1 plus 1. All right, plus 2 over e. 1 over infinity, that's 0, so I get minus 0 plus 2 over e. I get 2 over e. Alright, so if this was a solid problem, I needed to use improper integrals, so limits. Then I needed integration by parts. And then I used FTC to evaluate the 2 parts. And then at the end, I needed L'Hopital's rule, because what I had here is infinity over infinity.